Did you ever wonder where that yummy cod in your fish and chips comes from? Have you ever eaten mussels or oysters? Or how about that delicious halibut your grandma makes on special occasions? So where does all this seafood come from? Sure, some of it's caught by fishermen. Well, not quite like this anymore. More like this. But by the 1990s, a combination of factors like technological changes to how fish were caught, ecological changes, and the use of large factory trawlers caused the cod fishery to fall to 1% of its previous levels, ending the region's 500-year dependency on cod fishing. A moratorium on fishing was imposed in 1992. It was the largest industrial closure in Canadian history, and it was felt most here in Newfoundland, where over 35,000 fishers and plant workers from over 400 coastal communities became unemployed. So where does all this seafood come from? Much of it is the product of aquaculture. Aquaculture is farming on the water instead of on the land. Generally, it's farming of fish, shellfish, and aquatic plants in fresh or salt water. Here in Newfoundland, most fish farms raise cod, salmon, trout, oysters, and blue mussels. But it's hard to make wild animals grow in a predictable way in captivity. So the people here at Memorial University's Ocean Sciences Center Joe Brown Aquatic Research Building, or JBARB for short, work with aquaculture industry professionals to improve the productivity of working fish farms and develop new kinds of aquaculture projects. At JBARB, scientists, students, and researchers come together with businesses to figure out the best way to raise salmon, cod, halibut, trout, mussels, oysters, and even lobsters. But let's take a look inside JBARB and get an idea what really goes on here. The heart of the facility is the mechanical room. You can't raise seafood without lots and lots of clean, temperature-controlled seawater, and this is where that water is processed. Thousands of liters of seawater are pumped from the bottom of Logie Bay to this room, where it runs through sand filters, heat exchangers, oxygenators, UV sterilizers, and is basically made to fit the needs of whatever the scientist is studying. Staff at JBARB also maintain a brood stock of diverse fish that are used as the parents for fish destined to be raised for food. The eggs from these fish are collected by special machines and moved to incubators. Conditions in the incubators are specially controlled to ensure the maximum survival of the fry. If you're going to raise thousands of fish, you better have lots of fish food. Scientists at JBARB grow their own. Rotifers, artemia, and algae are grown to feed the fish and shellfish here at the facility. Big fish eat pelletized fish food, but the fry need live food. Rotifers and artemia are tiny prey for growing fish, and algae is used to feed oysters and mussels. They grow lots of fish food here at JBARB. When the fish are big enough to eat pellets, they're moved to big tanks where they grow, waiting their final move to the fish farm. When the scientists think the fish are big enough, they're moved by truck, then by boat to floating pens in sheltered bays in Newfoundland like this one, where they'll be raised for the next 3 or 4 years until the fish are finally full grown. Then it's time to harvest them and process them into the fillets we love to eat. But workers at JBARB do more than help fish farmers raise cod, trout, and salmon. Work is being done on oysters, mussels, as well as sea cucumbers and sea urchins. So the next time you take a bite of salmon or a spoonful of fish chowder or crack the shell on a lobster or sit down to a plate of fish and chips, think about where that seafood came from. There's a pretty good chance that scientists like the folks at JBARB were involved in helping bring it to your plate.